Okay, in this video we're going to go on to look at some of the word problems, starting with number 33. You're designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. And we want to write an equation that represents the total cost in dollars of the stickers as a function of the number in thousands of stickers ordered. Then we want to find the total cost for 9,000 stickers. So this problem is a little bit different than other problems that we've worked with. In some problems we work with an initial fee, a setup fee, an installation fee, some type of one-time base fee, and then we had to pay for each foam hand, each month of service, etc. that we used. But in this case, part of the initial fee is going to include 1,000 stickers. And then we're going to pay an additional amount, a much smaller amount for each additional 1,000 stickers that we use. So I'm going to suggest in this case that we start off by making a table of values, where one column represents the number of stickers we're going to buy and the second gives us the cost. Now we do know that for the first 1,000 stickers the cost is $225. If we wanted 2,000 stickers though, the cost would be $225 plus an additional 80, or $305. If we wanted 3,000 stickers, the cost would be $305 plus another 80, or $385. And we could go on from there. 4,000 stickers would cost us an additional $80, and that would be $465. Now, once we have this, we can do what we've always done, and that is to find differences between pairs of points. So the sticker numbers are going up by 1,000, where the cost values are going up by 80. And so our slope, we can see the slope between every pair of points, every two pair of points, is the same. And that slope is the change in y over the change in x, which comes out to 8 over 100, or 0.08. What does that mean? That is the price per sticker that we're going to buy. So what we need to do now, in order to write an equation that represents the total cost in dollars of the stickers as a function of the number in thousands of stickers ordered, the number in thousands. So what they actually want here is, instead of 1,000, just use the number 1. Instead of 2,000, use the number 2. 3,000, use the number 3, etc. And I'm going to go ahead and just continue to use the thousands that I've already set up here. So we want to write y minus y1 equals m times x minus x1. We want to write the equation in point slope form. We know what the slope is. It's 0.08. Let's take any pair of points. We'll use the first one. Y minus 225 is equal to 0.08 times x minus 1,000, and we can begin to multiply out. Y minus 225 is equal to 0.08x, and then minus 0.08 times 1,000. We'll use our little calculator. So 0.08 times 1,000 is going to give us 80. And so we have 0.08x minus 80. We're simply going to add 225 to both sides. And we end up with y is equal to 0.08x, and then 225 minus 80, and that would be 225 minus 80 equals 145, and that would be plus 145, and we end up with this equation. Notice that that $145, which is kind of like a setup fee, never shows up in this problem anywhere. So this is a fairly different problem than ones that we've worked with, but it is something that is very real world, and many companies charge something like this. They charge a higher fee for the first 1,000 and then a much lower fee for additional ones. So if you wanted to find out basically what you're paying is you're paying 8 cents per sticker and $145 for a setup fee. So let's write that down. So you pay a setup fee of $145. That's a one-time fee, and 8 cents for each sticker, except that you have to buy the stickers by the 1,000. Okay, so you pay 8 cents for each sticker, assuming that you buy the stickers by the 1,000. Now the last thing that we wanted to do here was find the total cost for 9,000 stickers. X represents the number of stickers, and so we would have y is equal to 0.08 times 9,000 plus 145. Bring up our calculator, and we get 0.08 times 9,000. Oh, that's too much. 0.08 times 9,000. That's equal to 720 plus $145 is equal to $865 for 9,000 stickers. Okay, so that's going to do it for this example. We'll go on to the next one. Okay, in this example, you pay a processing fee and a daily fee to rent a beach house. The table shows the total cost of renting the beach house for different numbers of days. For 2 days, you'll pay $246. 4 days, you'll pay $450. 6 days, you'll pay $654. 8 days, you'll pay $858. So, A, can the situation be modeled by a linear equation? Explain. So, the first thing that we want to do is look for the slope between each pair of points, each consecutive pair of points. So the x values going up by 2 each time, that's a good sign. Then between 246 and 450, we would have $204. Between 450 and 654, we have $204. Between 654 and 858, we have $204. Another good sign. So the slope between each two pair of points is going to be the same. What is that slope? That slope is m is equal to the change in y over the change in x, 204 over 2, which is $102. What does that mean? $102 is the daily fee to rent the house. All right, next. What is the processing fee? What is the daily fee? So first of all, can it be modeled by a linear equation? Yes. because yes, slopes through every two pair of points is the same. Alright, so we found the slope that is the same between every two pair of points. Next, what we want to do is to put the equation in point slope form. Y minus y1 is equal to m times x minus x1. How do we do this? We're going to pick any point. Let's take the first point, 2 and 246. Y minus the y value, 246, is equal to m 102 times x minus the x value of 2. Finally, we're going to simplify this down, or distribute, and we get y minus 246 is equal to 102x minus 204. We add 246 to both sides. When we do, we end up with y is equal to 102x plus 42. And what does that tell us? Well, we already know that $102 is the daily fee, and so therefore $42 is the processing fee. And finally, we're looking for, to answer question C, we can spend no more than $1,200 on the beach house rental. What is the maximum number of days you can rent the beach house for? So there are two ways of going about this. One way is we can continue to expand. We can go from 8 to 10, increase by 204, and we would get 1,062. But we only have $1,200, so we can't add another 204 on, otherwise we would be up to $1,266. Instead, we're going to just go up by 1. When we do that, we don't go up by 204, we go up by 102, and so that would be $1,164. So the most that we can stay is 11 days. We can stay 11 days. Alright, so that's one way to do it. I'll show you quickly one other way that we could figure this out, and that would be set y equal to 1,200 and the right side equal to 102x plus 42. Let's subtract 42 on both sides, minus 42, and that gives us 1,158 is equal to 102x, divide by 102, divide by 102, bring up our calculator, and we get 1158 divided by 102 is equal to 11.35, but we can't stay 0.35 days, and so so x is equal to 11.35, which means again that we can only stay for 11 days. Since we can't stay, they won't allow us to pay for 1/3 of a day. And so that's going to do it for this problem and for these two real-world problems using linear models, linear equations, and point slope form and slope intercept form. Okay, we have one more problem in the next video, and we'll